Welcome back. So you've hit Tyler Nelson twice now in a row. We're going to hit him again, but this time it's a different topic. It's refrigerant leak checking. We're going to cover everything from electronics to ultrasonics to UV dye to good old fashioned nitrogen and soap bubbles. So listen up, guys. This is a good conversation. You'll probably learn something here, or just maybe a refresher. So let's get to it. This is the HVAC Know It All podcast. I'm your host, Gary McCreadie. This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out. All right, Tyler, you're back. Thank you for joining us again, gracing our presence again with your passion of the HVAC industry. It shines through very, very. It's very easy to tell that you have a passion for the trade.
Well, thanks, Gary. Appreciate it very much, and thanks for having me on again and allowing me to punish your audience one more time. So that's good.
Hey, these are 2-part series. If we talk for like 45 minutes, so they're actually getting punished like potentially 4 times over the last 2 conversations we've had. So, refrigerant leak checking. It's almost like a science. I hate when people say it's an art, because art to me is, I've gone through this before. Brazing is an art. No, it's not. It's a basic skill. There's no creativity involved in brazing, unless you have to hang upside down and braze from like a weird position, and then now you're throwing your creative spin on it. Anyway, I don't want to call it an art, because it's more of like a science, because there's different things that can happen within leak checking a refrigeration or HVAC system, air conditioning, heat pump, whatever it may be. There's completely out of refrigerant, there's slightly out of refrigerant, almost out of refrigerant. There's leak checking with electronic leak detectors, UV dyes, there's using ultrasonics, there's using the old school nitrogen. And I mean, when you talk to someone like John Pastorello from Refrigeration Technologies, he's like, it's not soap. It's a leak detection formula that they've made to create a bubble system that outweighs that of soap. And soap from Walmart is corrosive, so you shouldn't be using that anyway. So I'm going to start like this, Tyler, and then you give me your thoughts. When someone says leak soap and bubbles, or leak soap and nitrogen is all you need. So there's guys out there that will attack a refrigerant leak like that. Let's say they go up to it and they run the system and it's short. There's people out there that will still remove all the refrigerant, pressurize it with nitrogen, and go around and just spray soap on everything. I mean, that is so 1985 to me. Nowadays we have, and I got one of yours, shameless plug, right? We have one of your Sauermann leak detectors here, and we'll get into this tool later on. If we have a good electronic leak detector and there is refrigerant in the system, that is my go-to, and I would never back down from that. Tyler, thoughts?
Yeah, it's like a doctor using more advanced technology nowadays to work on you and run diagnostics on you. So for me, it's the electronic leak detector is critical in my arsenal, because I can go after and find something significantly quicker, and it's not where we start off. When we get into this, Gary, what we want to do is first, obviously, ask the customer, listen, before we even get going, have you ever added refrigerant to the system that you're aware of? And then kind of go through a query with them, and then start to look at the usual suspects, check the condenser. Do we have residual oil sitting at the bottom of, by the compressor? And now, because refrigerant is going to go top down when it leaks, and you're going to have oil staining, you're going to have viscosity. If there's a puddle of water down there, you're going to have some viscosity in it if there's oil in it. But even taking a sideward step from that, you can use your leak detector, your refrigerant leak detector there. I mean, you mentioned about coating everything up with soap bubbles. Again, it's more of an antiquated approach. Now, some of the basics are very good at the way we do things, but I can take an electronic leak detector and I can basically haze it over joints and connections and TXVs and everything else and find something significantly quicker than dousing an air conditioning system or air conditioning components with soap bubbles like it's some kind of nightclub act in Vegas. And it's not the point. The point is to work as efficiently and as cleanly and as effectively as possible. That's where the refrigerant leak detector comes in. I could do it much faster. I'll bring in soap bubbles. If I know it's there, if I find it in a rough spot, I'll bring in soap bubbles to do it. And then and we have to be careful of the soap bubbles, because if you're inexperienced when you're spraying it on, you're seeing the bubbles form right away. No, you got to slow down for a second, because let those soap bubbles settle, and then it will almost look like pus on a wound, where you'll see them bubble out, or it'll look like you have kids and you coach soccer and everything. See one of the kids upset and they cry and they have a little bubble coming out of their nostril. It'll look like a little nostril version, or a little bubble like that from a nostril that you'll find. And that's where the soap bubbles come in, but it is not the only approach. I have, and I appreciate the passion comment earlier, a passion for marrying old school ways of doing things with new technology. I'm not a big fan of abandonment, especially when things have worked for many years. But what we want to do is we want to assimilate the latest in technology in with what our approaches were in the past. And that's where, again, we can marry soap bubbles into our arsenal, coupled with electronic leak detection. But to think that you don't need one or shouldn't be using one, that it's not necessary, to me, just it doesn't make sense in today's modern world, especially with the precise nature of the technology we're dealing with nowadays, where things are very expensive. So if you misdiagnose something, the cost that could be substantial for somebody.
Mm-hmm. Yeah. I mean, the only real time I will pull out nitrogen to leak check a system is if it's completely out. There's nothing in it. And most of the time when there's nothing in it, I would say most of the time, because sometimes there's different variations of this, but most of the time, if there's nothing in it, the leak is substantial. And a lot of times you can hear it. If it's a quiet environment and you stick nitrogen in there, you can hear it. And this is what I'm going to say about adding nitrogen. Don't waste your nitrogen by just going to 400 psi right away, because that is a resource in your truck, and you want to preserve the resource for different calls and stuff like that. You're not going back and forth to the supplier. Go up to 50 and see if you can hear it.
Yeah.
If you can't hear, go up to 100, and then, you know what I mean? Go up in stages, because if you go up to 400 right away and you hear it, now all that nitrogen is now just a wasted resource, right? That you just paid money for and whatever. So do you think that's a good way of doing it? I know a lot of manufacturers actually, even like, for instance, Mitsubishi in their manual to leak check also wants you to go up in stages too when you're leak checking their system after putting all the connections together.
What I call it is feathering it in. So I like to feather it in. I like to gently bring that pressure up on the nitrogen and do it that way, instead of being gluttonous with it and going. Me in the past you would shoot straight to 300. If someone's going to shoot straight to a shot, a lot of times they're going to shoot straight to 300 because they know that's roughly a safe bet. But I would feather it in, as you said, 50 at a time, and then see what you get, because it is a resource. And you know better, you do better. And if you could save that resource and get your job done quicker too, that just makes it all the more of a logical approach. But going back to what you said, I'm going to attack it that way when I know it's flat out. And as you start putting the nitrogen in there, a lot of times you can hear it. And if you're paying attention, especially, if it's, depending how big that leak is, and obviously outside, you're going to really hear it coming out. Even in the inside, even on the evaporator coil, you can even hear when the system's pressurized, you can hear that going.
Yeah, for sure. So the other thing that I wanted to talk about was, if it is a small leak and you've added nitrogen, you can't find it, you're not going to be able to use an electronic leak detector at that point. So there's ultrasonic leak detectors that can pick up sound really, really well. You have to get used to that sound. So you almost have to like practice like on an actual leak and say, okay, that's what a leak sounds like. Okay, how do I differentiate between the leak and just like an ambient sound that's happening? And the other thing that we can do there is we can get, instead of wasting your liquid leak detector or detection formula, we can get a bottle of water, or in a spray bottle, some water, and spray it over fittings and joints and coils. And that water over that coil will actually help to make that sound a bit easier to detect while using that ultrasonic leak detector.
Yeah. And going to your point too, even before attempting this, as you said, getting used to what it sounds like on a system that is leaking. That's another thing with just leak detectors in general. And the reason I say that is learning on something that is leaking, or in a test environment, that that you can trust that leak detector. There's a lot of times when guys are using things, I don't know if it's working or not. Trust it or try it in a a prefabricated type of an environment where you know there's a leak, so that you can trust the device. You know it's going to pick it up, so that when you take it out and go to use it in practical application, that you know what you're doing. But yeah, it's when it is flat out like that, you can take that spray bottle and you could put some water in there, and it will change the pitch of some things and the way that things sound and the way that they go about their broadcasting what's going on there, for sure.
Yeah. I check my refrigerant leak detector, my electronic, every time I use it before I go searching for the leak. And the easiest place to do that is a Schrader core. People online that'll say the brass caps or even plastic caps that the manufacturers put on from the factory are only dust caps. They're not there to prevent leaks. That is the biggest BS I've ever heard in my life, because Schrader cores are pennies a piece and they leak all the time. If you don't put those caps on and you've got a core that's not seated right, even though it's losing refrigerant very, very slowly through the course of a summer, then through the course of a winter, you're going to come back and go, why is this thing low on refrigerant?
All right.
And it could be through the Schrader core. So those caps are not just dust caps. They don't just prevent dust from getting onto the fitting. They are actually there to prevent leaks as well. I even put a little bit of nylog in mine, and I screw them on just for that added protection.
The inspectors by us, where I live in the state of New Jersey here, they, in towns where we don't put the locking caps on, the Schrader caps on, after you install, they will fail you on your inspection. Which is like since maps. Yeah. Yep. If you don't put the locking caps on, they're going to fail you at your inspection. And if we don't have them on there, so because they don't want the kids huffing the refrigerant too, we're trying to huff refrigerant. So there's all that. But yeah, I can't tell you how many times we instructed the installers to put the locking caps on, and then they said they did, and then the inspectors come and the homeowner goes, yeah, hi, can you send your guys back? Why? You failed inspection. Why? So they got some kind of locking cap. I'm like, you kidding me? Now I got to send somebody back. So yeah, you're right. It does leak from there. You want to keep those caps on there. It's dust, yes, but it's also a sealer because there's a little pin in there that connects everything. You want to put those on there for sure.
So I think what I was getting at with so I test my electronic leak detector at the core. A lot of times they're leaking. If not, I get my little pocket screwdriver and I just a little touch just to see if my refrigerant leak detector is picking it up and working before I continue. Because what if you leak check an entire system and you're like, oh, there's no leaks in here, but your detector actually is having an issue detecting refrigerant. So always do a little pre-test first, right? Would you agree with that?
Agreed. 100%. So you can trust it 100%. It's a lengthy process, Gary, and it can be a very expensive process too, especially misdiagnosing something. It's because when we get involved in this is when you said it's a science. Some of this is a science, or even brazing. It's a science and not an art. Yes, but some of it takes a lot of interpretive nature. You have to be able to analyze the situation too. You have to have a nice visual way to inspect things, look for the staining, look for that residual oil, look for those different things in a system, especially if it's outside of the condenser. It's going to leak fast and it's going to go everywhere, outside, and it's going to be quick. So you're going to see that especially if a system is straight out, a lot of times you're going to find it from there. We've seen a lot of times where we have a lot of people here that use landscapers because they have the ability to afford that. A lot of them work in the city, so they use landscapers to do their stuff. Well, I can't tell you how many times landscapers have cut a line set with a weed whacker, and getting too close and trying to get the grass away or the clipping or whatever away, and they've snipped it and not even knowing it. What happens is snips are right in the insulation. You don't see it because the insulation is almost seals itself back up again. But then you could either hear it spitting out, or when you go to pressurize it, you can hear it right down there. And that goes back to your point of going 50 at a time, 50 psi at a time, because you'll hear it coming out right at that spot there.
So there's something that I've found a lot, and the word, let's put this word out there, formicary corrosion, and I'll just explain what that is to people that don't understand. So the copper at a microscopic level and will start to leak through its pores. You can't actually, sometimes you don't even find bubbles there, or you would need a microscope to see a bubble there because it's just so minuscule. It's like It's like a leak that you're not going to be able to see with your eyeball. You might, depending on how good the solution is that you're using, if it starts to create that foaming bubble action over maybe 15, 20 minutes or something like that. But the techs that go and fill the system up with nitrogen and leak check everything with soap, you're not going to find formicary corrosion on a coil, especially if it's buried in the coil. So they'll take the refrigerant back out, they'll pull a vacuum, and they'll charge it back up, and then the next summer it'll be short a half pound of refrigerant and not running properly, and they'll go through the same process again. Well, these evaporators leak like sieves. There's household chemicals that play a part in this. I know that the thinning of the copper for better efficiency has played a role in this, but there's also household chemicals that are circulating through the air and stuff like that can also be corrosive to the coil and start eating it from the outside in and creating this formicary corrosion, also called ant nest corrosion. Because when you look at it through a microscope, the copper wall, it looks like there's all sorts of little different tunnels and stuff going from one place to another, and that's actually microscopic cracks in that copper. So the only way you're really going to detect that are two ways: with an electronic leak detector, or sorry, three ways: with an ultrasonic leak detector, or the first time I ever encountered this was many, many years ago. It was with UV dye. And this was my first encounter with UV dye, and I was like, wow, what a visual. So what it was is there was a Liebert coil in an old server room. And if there's UPSs inside a server room, I've talked to people about this at work in data centers a lot. It seems like it corrodes the coil quicker for some reason because there's batteries, right, inside the data center. So the UPSs are run off batteries, and I don't know if the battery acid somehow leaks out and gets vaporized, kind of circulates in the air. I'm not quite sure because I haven't looked at
Creates VOCs in the air. That's what it does.
Yeah. So there was this one old Liebert unit. It was giving issues, and my boss is like, go put dye in it. So I did. And we went back like a week or two later and put a UV light underneath. And it's a big A coil, right? And you got to get in the blower section and shine it up. And this thing lit up like a Christmas tree. There was leaks everywhere in this thing. And we wouldn't have back then, the electronic leak detectors weren't very good. If there were any back then when I did this, they weren't very good. And this was the way to find it. And we brought the customer in, hey, look up there. He's like, wow, okay, changed the coil. So two things happened for me that day. The visual told me what was going on, and the visual told the customer what was going on, and it made him act upon the thing, right? Because without seeing that visual, who knows? He might have just said, yeah, can you try to fix it? Or who knows what the conversation would have been. As soon as he's seen it, he's like, yeah, we need a new unit. We need a new unit, right? So give me your take on UV dye in general. I've used it strategically through the years. There's people that say never use it. It's going to clog a system. It won't clog a system if you use the right one because it's just highly refined lubricant. So give me your take on UV dye.
We've used it quite a bit over the years. I found it to be a useful tool. Going back real quick, just 2 seconds to your formicary corrosion. What you noticed when you saw those leaks from it, they were larger, but it wasn't, the holes weren't bigger because obviously they're microscopic, but the spread was larger because it's almost like a mesh type of an appearance to it almost when it leaks that way. One of the things we saw with that similar type of thing when we did UV dye was we noticed it where we came into a customer after the fact and they, for example, the split system, it was a condensing system and they didn't have a fresh air intake. They were pulling fresh air from the inside of the basement, and people had paint solvents, open bleach canisters and everything else, kind of the stuff that when we joke around in a combustion presentation, when I talk about it, and I learned this from Jim Bergman, what destroys heat exchangers the most? Service technicians and homeowners. And that's one of the ways that homeowners can destroy their own equipment is having, especially with obviously the installer should have installed it correctly using fresh air intake. But when you're pulling those properties from inside that space, which might be less than 20.9% oxygen because there's other things infiltrating it, and you're not pulling fresh air from the outside, that's an issue. So, and that will cause those kinds of that almost like same kind of corrosion on a system on a residential standpoint. So going back to your question, we used it quite a bit, and we found it to be effective. Up until even fairly recently, we were still using it and even in job sites I've gone to with customers of mine that are contractors, obviously we've been using it and they've been using it and it's been effective. You have to let it run through the system. That's the other thing too. You charge it you want to let the dye run through the system. You have to put a little bit of refrigerant in there to get them up and running, but you have to let them know, and listen, I have to come back for a secondary appointment. I don't know where this leak is yet. Couldn't find it from conventional methods. This is my next point of attack. And we had good results with it. It wasn't a cure-all for everything. It wasn't a perfect answer, but we did much more so than not have very, very good results with it. So it's something that as long as you're using the proper dye, it's something that I believe in using. It kind of goes to, maybe to your next point too, if we're going to jump to something different, is using the leak sealers in systems, and that's a whole different thing. But the UV dye insertion, yes, we're very successful with it. Something that I stand behind if it's the right one.
Yeah, I want to talk about leak sealers too in a few minutes.